We're going to finish up Unit 10 by going on a vector voyage. So let's read the instructions because that's always a good thing to do. Dead reckoning is used in navigation. It is the process of determining one's position on the globe. This is done by estimating the direction and distance traveled by moving from a known position. Ancient navigators like Columbus used dead reckoning to navigate and determine where they would end up. Unfortunately, Christopher Columbus never reached his desired destination. Navigators estimated their position by calculating the direction and the distance they had traveled from a set location, like a port. Direction and distance the ship can travel are not the only factors that determine a location. Other factors, including wind and ocean currents, could change the ship's overall course. Early navigators used math and vectors to try to stay on course with these added factors. For this activity, your ship will always be pointed due west, and the ship is going to be able to travel 7 squares due west every single week. So we're going to indicate this with a red colored pencil or a marker, whatever. Pencils are going to work really well. I'm actually going to use a vector drawing tool, so let me show you how this works. We're going to start from Spain, and here's what's going to happen on week 1. On week 1, we're going to travel 7 squares directly west. So we've got 1, 2, 3, 4, 5, 6, 7. I'll give you a little hint. Every single time it's going to end up at one of these little cross marks right here where two of these lines, a vertical line and a horizontal line, intersect. So that is week 1. Now, if you can do it in red, that would be great. I'm just going to write down week 1 right here and indicate it that way. I suppose you could do this if you just had a pencil, but it would be better if you had the colors to this. So let's go ahead and take a look at part 2. But before we move on, let's make sure that we answer all of the questions here. So I'm not going to answer these, but anytime there's a question or there's a blank, make sure you fill that in. So here's the deal on part 2. We're going to add a wind vector on every single one of these. So each week is going to have the ship heading to the west, 7 squares per week, and then we're going to add a wind vector, and it tells us on week 1 that the wind blows at 2 squares directly to the north. So here's what that's going to look like. So let's show the ship vector again. So the ship would look like this, again, 7 squares directly to the west, and then we've got 2 squares to the north for the wind. So the wind is actually going to push it to the north. So let's bring that vector in. So it looks like that. And then we would do a vector addition problem. This is all set up for tail to tip. So that's why we put the wind vector right at the tip of the ship vector. So we're going to go from the tail of the first one to the tip of the last one, and that's going to look like this. So this right here is week 1. So I'm going to label that as week 1. And again, if you needed to, if we wanted to put an S here for the ship and a W here for the wind, that would be totally okay. And then we also want to figure out what was the actual distance that was traveled there. Well, we know this was 7 and we know this was 2. So if we use the Pythagorean theorem, or we know how to find the magnitude of a vector in component form, here's what we'd get. This would be the square root of, horizontal component is 7, so we'd square that. Vertical component is 2, so we'd square that. So we end up with, let's see, this would be 49 plus 4, so this is going to be the square root of 53. So we'd say that this distance right here is the square root of 53, all right? Now, down below here, I'm not going to finish any more of this, but down below we are going to talk about some of the questions. It says each square represents 100 miles, so we could figure out how far this is in miles. How far did they actually go in miles? So I'm going to bring up the calculator here. And remember, we figured out that it was the square root of 53. So I'll hit second square root, 53, hit enter. So that's going to be 7.28. So this distance right here, again, it's represented, each square is 100 miles. So this is 700 miles to the west, 200 miles to the north. So altogether, this is going to be 728 miles. From here to here. Now, you don't need to worry about that to the end, but you do need to be able to add up all of these weak vectors, figure out where you end up landing, and then you're going to need to use distance equals rate times time in order to figure out some of these other questions here. So this would be d equals r times t, and we want to know, like, for instance, the speed. So we could take the distance, and we could divide it by the time, and that would tell us what the rate is, or the speed. So we just divide both sides by t. T would cancel here, and then we get d over t equals r. So that will help you figure out what the speed of the boat is. So enough of that, and let's take a look at the next page. All right, part 3 is where it really starts to get interesting, because we've still got the ship vector. It's going to be heading west at 7 squares per week. Then we've got our wind vector in green, and then again, those are indicated here. And then the blue vector is going to be the ocean current. So on week number 1, the ship is going to still head west, so let's put that one on there. It looks like this. And then we've got a wind vector that's 2 squares to the north. So 2 squares to the north would look like this. So there's the ship and there's the wind. Notice that we did the tail of the wind vector to the tip of the ship vector. And then let's bring in the current vector. The current vector actually pushes it 4 squares directly to the south. So the current vector would look like this. Now notice how I offset those just a little bit. Now what we have here is we've got 3 vectors that are added together using the tail to tip method. So let's see, we'd go from the tail of the first one to the tip of the very last one, just like we normally do, and we end up with this right here. So this is going to be week 1. So week 1 is going to be right here, and you'll notice that we went 7 horizontally, and then we ended up just going down 2 vertically because the northern wind was offset by the south current, so we end up like this. This is again 7 and 4, so you can actually figure out that this again is radical 53. So that would be the distance, that would be the magnitude of that vector for week 2. Now, I'm going to do a completely different one for this next one. So we're not going to do this, we're not going to do that week 2. We're going to do a different week 2. So I'm going to make one up. So watch what happens here. So let's say the ship is headed west like it normally is. So we'll bring in that vector. So there's the ship. And then let's say that the wind does this. Let's say the wind pushes it 4 squares directly to the north. And then let's say that the current is actually heading in a northeast direction, so it actually pushes it back 2 diagonal squares to the northeast. So we're going to go from the tail of the first one to the tip of the very last one. So this is what week 2 would look like. So I'm going to go ahead and label this as week 2. So week 2. And then we'd have to figure out what this is as far as magnitudes and in directions and stuff like that. So we would go over 1, 2, 3, 4, 5. So this is actually 5 squares to the west. And then we'd go up 1, 2, 3, 4, 5. Let's see, is that 6? Yep, that's going to be 6 squares to the north. So this is 5 and this is 6. And then we can use the Pythagorean theorem or the formula for magnitude of a vector in order to find out what the magnitude is right here. So we know how far they actually traveled. And then again, you're going to be asked questions about where you made landfall, how fast were they going, and different things like that. So again, each week is like doing a vector addition problem with 3 different vectors. So you'll do the tail to tip and another tail to tip, and then just like always, we're going to go from the tail of the first vector each week to the very tip of the last vector for each week, and that's what it's going to look like. So that should be a good start. Good luck with the assignment.